Hello and welcome back to one more tutorial in the Gemini series. Today, I'm very excited to talk to you about multimodal AI. So in this session, I'm going to explain you what is multimodal AI and then take a closer look at Gemini's multimodal capabilities. So I have interesting demos lined up where I'm going to walk you through images plus text as prompts and then using just images as the prompt, followed by an interesting demo on performing semantic search with images based on Gemini multimodal embeddings. So let's get started. So what is multimodal AI? Well, multimodal AI takes multiple different modalities as input. Now, what I mean by modality is, till now, we have seen how to use text as the prompt to generate text. But what if we are able to provide prompt in the form of not just text, but also an image or video or even audio? Of course, you can even combine that with an image. For example, you can input an image and then have a prompt that asks to summarize the image or describe the image or write captions for the image. And then the multimodal AI comes out with content. So this content is typically text, but eventually multimodal AI can even generate additional images. But Gemini is essentially a combination of text plus image plus video prompts, which will generate additional text. So we will take a look at how to use Gemini's multimodal capability through Vertex AI, and then how we can use the Google AI Studio, which is the straightforward library to use the multimodal capabilities, to get multimodal capabilities of Gemini to that. And then the last demo is where we will explore the capabilities such as semantic search. So let's get to the first demo where I want to walk you through how we can use image as a prompt. All right. So let me give you a quick overview of my Python modules. So this is the requirements.txt where I have Google Generative AI, Google Cloud Platform, ChromaDB, Pillow, and Jupyter. So Pillow is meant for image processing. ChromaDB is for storing the vectors, which is a vector DB. And then Google Cloud AI Platform is needed to deal with Google Cloud Storage. Generative AI will use the AI Studio based Gemini to access the API. So those are the requirements. So let's look at the first demo. So the first demo, I want to use image as a prompt and generate the response from the model. So the first demo will basically use the generative AI module, which is talking to the Google AI Studio. And this also assumes you got the API key and initialize the environment variable, which is Google API key. So to test if you're able to hit the endpoint and your API key is correct, let's look at the models. So this confirms that we are able to access the models. So we are interested in Gemini 1.0 Pro Vision latest. So this confirms we are able to access the models. Then I'm going to use the Kilo image processing module to basically open an image called tiger.jpg. And when we print this, it looks something like this. So we'll send this as a prompt to the Gemini Pro Vision model, which is the multimodal AI from Google. And then look at the response. So let's generate the content and print the response. So now this is going to send the image as the input prompt instead of text, and then it comes back with the response text. Now this might actually have a lot of details about what it is seeing in the picture. So it says the tiger is the largest cat species, and it came back with a lot of details about the picture. So as you notice, the multimodal capabilities are basically meant to accept either text or image or both as input prompts and generate relevant content. So in this demo, we have seen how we took an image called tiger.jpg and used that as the input prompt instead of text. So in the next demo, we'll use a combination. We'll send the image as well as a textual prompt to get what we want out of the model. So let's switch to the second demo. All right, there are two major changes in this demo. Number one, we are going to use Vertex AI based model, not the Google AI Studio. Second, we'll use a combination of image and text. So let's get started. First, I'm going to import the modules, and all these modules are based on Vertex AI. And the other change that I want to show you is how we can upload an image to Google Cloud Storage bucket and use that as an input to the model. So that's the reason why I imported Google Cloud Import Storage. So let's initialize the model and a set of variables. First is the bucket name and then the file name. And of course, I'm going to initialize the model, which is Gemini 1.0 Pro Vision. And then I have a couple of helper functions. So these helper functions will deal with Google Cloud Storage. The first one is create bucket. It accepts a bucket name and creates it if it doesn't exist. The second one will simply take a local file and uploads it to the GCS bucket. So those are the two helper functions. And once we have those, we will go ahead and upload the image to the GCS bucket. But before that, let me show you how the image looks like. Well, this time I want to use a movie poster from The Godfather, which is an iconic movie in the history of filmmaking. So this is the image that I want to upload, and then associate this with a textual prompt. So this is currently loaded from my local disk. So what we'll do is first we will create a bucket. And if the bucket already exists, it just ignores. And after that, we will go ahead and upload the movie.jpg file to the bucket. And then let's make sure that the URI is constructed properly. So this is the bucket name, Johnny Gemini demo, and then movie.jpg, which is the file name. So with that in place, we are good to go with the next step, which is nothing but the invocation of the model. So first we will pass the image, which is coming from the GCS URI, which is visible here. And then we are invoking the model from the generate content. And here we are passing two different prompts. One prompt is the text prompt. Describe the plot of this movie, and then the image. So this is very subjective. It's like a placeholder. And Gemini is powerful enough to replace that with the image, with the movie name it finds in the image and describes the plot. So behind the scenes, there is a lot of heavy lifting. Gemini is now reading this image, it parses everything, it figures that this poster belongs to the movie The Godfather, and then uses the text prompt to complete the task. So let's go ahead and invoke the model, and then let's print the response. So it's going to take slightly longer than invoking the, not bad. It took a few milliseconds and then came back with The Godfather is a 1972 American crime film, followed by the plot. Perfect. So this is very powerful. This is really powerful. You can do a lot with the multimodal capabilities of Google. I want to give you one specific use case. If you are a mobile developer, you can build a mobile application that can accept an image coming from the camera. So you can point your mobile phone to an image, and then it can take your voice as input, your speech, convert that to text, and then send the image you captured from the camera and the speech, which is converted to text from the microphone, send it to Gemini, and then perform the task. For example, if you are at a historical heritage monument, you can point your app, the camera, to the mobile camera to the monument and say, describe what it is. And then Gemini will first find out what is the monument, and then it will help you understand more about it. You can actually point this to a mall or an iconic landmark and say, hey, what is the best Asian restaurant around this? Now, Gemini can really find out the location where it is, and then it can come back to you with the restaurants around that place. So it is a very powerful capability, and combine this with RAG, you can accomplish very complex tasks. Talking of RAG, I'm going to show you how you can generate embeddings and perform semantic search. Stay tuned. All right, with Gemini, it's not just about sending multimodal prompts. It is even about generating embeddings and performing semantic search and building complex RAG pipelines. So I want to show you a demo where we basically take image and text and generate embeddings. But why do we need to do that? Well, we can then store the embeddings in a vector database like Chroma and then perform semantic search, which we'll see in a minute. But first, let's understand how we can generate embeddings based on the images and text. So I start by importing the modules uh, and then initializing the model. So the image path is the local tiger.jpg, which you have seen earlier. And then I'm going to use the load from file method of the image class. And then I set the contextual text to Bengal tiger, and the dimension is 1408. So this dimension defines the size of the vector. So once we basically do this, we will go ahead and generate the embeddings for these two. One is the image, the other one is the text. So then we can look at the embeddings. First, the image. So the image embedding is a long vector. And if you look at the length of this vector, it is obviously 1408, which is the dimension that we mentioned here. And similarly, we can also look at the text embeddings, and the length is also going to be the same. So what I want to drive across is the ability to use the multimodal embedding model to generate embeddings for both text as well as images. So once we are able to generate these embeddings, we can store them in vector databases and perform semantic search, which brings us to the next demo. So let me talk to you about performing semantic search with images. Now, if you have seen my previous video, I have talked about RAG, implementing RAG with both Vertex AI vector search and Chroma database. Now, what if we are able to do something very similar but with images? Now, this is very similar to how you perform image search on Google. There is something called reverse image search. For example, you can click a photograph, or you find an image on the internet and then you upload it and you want to find the source or you want to find more details about it. Google can perform reverse image search and show all the similar images to the one that you uploaded. Now, implementing that is very straightforward when you have a multimodal embedding available to you. So let's actually see how that works. So first, I'm going to import the modules, and here this is including Chroma DB as well. And then the first helper function that I'm going to write is the gen embeddings function, which takes an image as input and returns the image embedding, like the one we have seen in the previous demo. And then it basically accepts the directory and generates the file names as the identifiers, the entire path, and embeddings which are generated by the model. So at this point, I want to give you a walkthrough of the images directory. So here you actually see that I have three directories within images. So when I go to cat, there are exactly 10 images of the cat. Similarly, there are 10 images of the dog, and there are 10 images of vehicle. Now, we want to generate embeddings for each of these files, store the path of the file as an identifier, which will uniquely identify the embedding, and then call the model with that image and generate the embedding. So this is going to return file names, the entire path, and the embeddings. So let's go ahead and run this. But I want to let you know that this is a slightly involving process. It might take a while because we are generating embeddings for roughly 30 images, and invoking this endpoint 30 times is going to take a while. So what I've done is I have already generated and cached the IDs and embeddings. And where did I cache? Within ChromaDB. So here you actually see that I'm using ChromaDB's persistent client, and path is vector DB or VDB, which means it is already in my directory. So if you go to VDB, it is already stored here in the form of a SQLite database. So Chroma has already cached the IDs and the embedding. So I don't want to repeat that process. It's going to take a while. So we will initialize the client and the collection. So the client, it is going to pick up from VDB. It's not going to create again. Images, this collection already exists in the database. So it is going to simply pick that up instead of creating it all over again. Once that is done, if we are running this for the first time, I have to add the embeddings. So IDs, which are nothing but the file names, and then the embeddings, which are the generated embeddings. So I'm going to comment this out because this is already done. But for the sake of completion and the entire walkthrough, I'm including that in the cell. So now it's time to perform the semantic search. So let's take an image, load that image and generate embeddings for that. So meanwhile, we show you what that image one is going to be. So image one is basically a cat's image, right? And what we want to do is we want to take this image. Let me print this to show you what we are loading. So obviously this is a fat cat sitting there. And then we want to perform a semantic search on ChromaDB. So we are now querying the collection and we are sending the image, which we generated here based on the embeddings. And we want to retrieve top 3 results. So when we run this, we get back a result that includes um, the IDs. So now you can actually see that it retrieved 3 cat images that come very close to this one. So now it's very easy for me to use these IDs, loop through it, and display those images. So for images in result for each ID, and simply load that image file name and show it. So now we have 3 cat images. So what did we do? We just did a similarity search on images, not text. Now I want to show you one more image. Let's say image 2, right? This is basically a dog. So now I'm going to load this image and perform a query. So first we generate the embeddings and load the image, generate the embeddings, pass that embedding to Chroma to perform semantic search, come back, and this time it picks up 3 dog images that come close to what we sent. Perfect. So now we are able to perform a semantic search on this. So finally, I want to show you one more image. This time it is basically a vehicle, a car. And now we'll retrieve all the images that look like this car. So end results is equal to 3, which means the top 3 results. And there we go. Perfect. So we just implemented an image search based on multimodal embeddings of Gemini and the semantic search capabilities of Chroma Vector DB. So you can do a lot with this. I have a small exercise for you. Think of it like a homework. So take this example and build a RAG pipeline based on images. Well, if you're not familiar with RAG, do look up my previous videos where I implemented RAG with both vector search on Vertex AI and ChromaDB with LangChain. So basically, RAG feeds the model with the context. So if you build a multimodal embeddings based RAG pipeline, you can embed an image, you can embed a prompt, and you are essentially feeding the context to the model by retrieving from a vector database. And now the model can answer very intelligently based on the context, which is actually an image and not text that you are feeding into it. For example, you can extend this to implement, describing a specific dog breed. So imagine you have a vector database of multiple dog breeds like the German Shepherd, the Labradors and Retrievers, and then you basically send an image and you perform a semantic search to retrieve one of the other dogs. You retrieve the name of the dog, which is also stored as metadata, and then explain the dog, the breed, and the attributes, the key properties of the dog. So that's how you implement vector databases. I mean, RAG pipelines based on vector databases, multimodal embeddings, and a capable multimodal AI like Gemini. So that is what is possible. I'm planning to do a very detailed tutorial and a walkthrough of multimodal RAG pipelines. Stay tuned for that. But meanwhile, you can go ahead and give it a shot. So that brings us to the end of this session, where we looked at the multimodal AI capabilities of Gemini. So if you liked what you have seen so far, please do subscribe to my channel and click on the notification icon. I'm planning to publish a lot of content on generative AI, coming from Gemini, OpenAI, the Hugging Face based open source models, and many more. So stay tuned and please do subscribe to my channel. I'll see you next week with another video. Thank you.